Welcome to this special holiday edition of Scaling Up H2O. Scaling Up Nation, Trace Blackmore here, and it is Boiler Tuesday. I hope you had fun celebrating pre-treatment Monday. I hope you've reached out to some of your water treatment brothers and sisters and wish them a happy industrial water week. Well, folks, you guys have answered my call a couple of weeks ago. I had asked the Scaling Up Nation to call into the show. And of course, we don't have a phone number. So you do that by going to our website, scalinguph2o.com. And there is an icon on the right side of the screen that allows you to record a voicemail that goes straight to my inbox. Nation, you did just that. We're going to play those recordings and we're going to make sure we answer the questions that you left for us. So our first question that we have is from David about a boiler.
Hi, Trace. My name is David in Alpharetta, Georgia. I truly enjoy listening to your show. I did have a question on boilers. What causes the foaming on my boiler system? And also, how could I reduce the corrosion in my boiler? I really appreciate it. Thank you.
Well, David, great question, and I really appreciate you calling in with it. First off, as I said yesterday, there's a lot of complexity when it comes to water treatment, and just the small amount of information that we're getting on these questions, there's just not enough data for us to accurately answer and figure out the precise cause. So I'm going to answer this very generally. Foaming can be caused by a number of issues. The most common reason that foaming is caused is because the solids in the boiler are too high. So perhaps we're running the concentration ratio too high in the boiler, or maybe there's an overfeed of something that's causing a lot of solids in the boiler. Now, what happens if you can look inside the boiler as water starts to boil, it breaks very easy at the top of the water surface. But what happens when the concentration gets higher and higher and higher, the water, when it boils, it doesn't break as easily and it starts to build up. Those bubbles start to build up on each other and they form a foam, almost like a shaving cream, if you will. Maybe not quite so thick, but they build up on each other and that can create a lot of issues. One of the issues that it will most likely cause is wet steam. And folks, I know you've heard that term before, but maybe it doesn't make complete sense. Why is wet steam such a big deal? Well, it's all about BTUs, British thermal units. And water on its best day can have 180 BTUs in it. Steam, however, on its worst day, will have 1,150 BTUs in it. So if we're getting water to carry over with the steam, we're not getting that 150 plus BTU powerhouse. We're now diluting it with 180 BTU water. So it's imperative for whatever that steam is going towards that we have nice, clean steam with the absence of water in it. Now, what happens as that foam builds on each other, those water bubbles, as they boil, they'll pop, and they're so high, they'll pop over and they'll suck out as the steam is going up through the steam header. So you'll normally see that with production equipment just simply not being able to function because there's not enough BTUs for that to work. Or maybe we can't heat something. So normally you'll see that issue because your customer's calling and saying, hey, my stuff doesn't work and I'm paying you a lot of money as my water treater. Come find out what the issue. And by the way, I'm blaming you until you prove yourself innocent. That's just how it goes. Now, most water treaters will simply just put defoamer into the boiler. And folks, that will solve the issue quickly right then and there, but it only solves this surface issue. As soon as that defoamer goes away, you didn't solve anything other than putting something into the boiler. So my suggestion is you take some time Try to figure out exactly what is going on with that boiler. What is the primary cause that's making that boiler foam? Once you find that, you're not going to need defoamer because now you fixed the issue. And if there's something that I have seen in working with other water treatment companies, it's that many water treaters will go to a simplistic solution that doesn't solve the root cause. So don't be that guy, don't be that gal. Maybe defoamer will get you up and running right now, but go ahead and take the extra moment to figure out what the root cause is, because folks, you're a water treatment professional and we are celebrating Industrial Water Week, which is the water treatment professionals holiday. So why not go ahead and do that? David's second question was asking about corrosion. Well, folks, we know that water's number one job as the universal solvent is to corrode. So water, against anything else, given enough time, water will win. You can look at the Grand Canyon if you have any doubts of that. So what do us poor water treatment folk ever have in hopes to combat against water? Well, we know that we can never stop corrosion, but we can slow it down to industry standards. So David, if you were in front of me, I'd ask you some more questions. Specifically, what type of corrosion are you seeing? Are you seeing something that looks like a shotgun on your boiler tubes? And typically, folks, that's very indicative of sulfite not working properly or your oxygen scavenger not working properly. And oxygen pitting, it always has that appearance that somebody took a shotgun and just shot it. So if it looks like that, it could be an oxygen issue. 9 times out of 10, when I try to investigate issues with corrosion in boilers, it's normally an operation issue, or more importantly, a lack of operation issue. So let's say that we're designing a new facility and we've got to figure out what type of boilers to put in there. Well, we know we're going to do more business, so why not buy a bigger boiler than we need so we can take care of those orders we need to fill 3, 4, 5 years from now? Makes sense, right? We just buy it once and now we don't have to totally retool the entire system. Well, that is a good solution, but what happens if they're not set up right and if they're not run the way that they were designed to run, they actually can damage themselves. So folks, if you have a certain PSI boiler and you're not running it at that designed PSI, realize that that was not how that boiler was designed, and we could actually be hurting that boiler just because how it's set up and how people are running it within that plant. So there might be a running issue. Another thing that people do is they'll have 2 boilers, so one can go offline and they'll have another one as a backup. And typically they'll run both in a lead and lag situation. That means one's coming on while the other one's waiting to see if it needs more demand, and that's when it will come on. Well, depending on how they set this up, sometimes they never put the lower used boiler in the number 1 position and vice versa. And the boiler that's not getting used, I guarantee you, will corrode faster than the boiler that is getting used. There's a dynamic property that happens with the treatments that we use. And folks, anything that we're treating, water has to be moving through them, and they need to be in the on and use position. So I've seen more damage happen to boilers that aren't being operated properly than any other thing. And then what happens here in the South, folks, you might not know this, but it doesn't get very cold here in the South. One of the reasons that I live here, we don't have a lot of cold weather. And what I mean by that, we don't get a lot of freezing weather. When there is ice on the ground, like 1/8 of an inch, they preempt every television show and they put it on the news. That's how weird it is down here in the South. So the people that have boilers for heating, what they will do when they're not using those boilers on that one day that it is cold, they put them into storage. And this is another way that I will see corrosion take place because they're not properly stored. Now, this could be a whole show in itself, and maybe it will be, but the simple point is that if boilers do not run, they are going to corrode. And now we have to do something up and above if they're not going to run to minimize that corrosion. The two things we can do is we can wet store it, which means we're going to completely purge the boiler of all of the air. So if we're going to go ahead and fill the boiler up all the way up into the steam header, right at the steam header, and that's going to be with heavily treated water, so we don't have to worry about corrosion taking place within that water. Now, depending on how long that boiler is being set up, we need to test that on a regular basis because it's all that product that we have in there, it's going to get used up, and we have to replenish that. And I've seen a lot of people that will wet store a boiler and leave it there for years. Folks, it doesn't work that way. The reason we all have a job is because those products get used up, and we're the professionals that need to know how much products to put back in there. The second option that we have is a dry storage, and that's more of a long-term solution. There's a whole host of ways that you can do that. I've seen people hang drop lights down in there. It's for a little bit of heat so the tubes don't condense water. I've seen people put fans in there. There are a lot of products that will vaporize and then form a coating on the metal itself that are out there today. There's a whole host of ways that you can dry store a boiler. But again, it has to be done properly to the method that you are going to use, or corrosion will take place. So, David, I don't think I really answered your question specifically because I didn't know the specifics of your question, but I hope I've given you some things to think about when your boiler is more corroded than it should be based on industry standards. Normally, there's a reason for that, and it's not necessarily a water treatment issue. Now, it can be. That's where everybody's going to look first. But normally what I have found is that it is an operational issue. So Nation, I've had a lot of fun yesterday and this last question answering your questions that you recorded on scalinguph2o.com. But why should I be the only one that's having all the fun? As you know, I am a strong believer that if you know something, you teach something. But I'm also a strong believer that everybody doesn't know everything, and you need a mentor to guide yourself through the incredibly windy road that water treatment is. Well, folks, you know that it took a village to build this water treater, and I've spoken many times about my dad, and I believe I've spoken about two gentlemen that are going to be on this show, one today, one tomorrow. Very imperative in the development of me as a water treater. And the first one that I'm going to introduce, I'm going to keep you in suspense for the one tomorrow, but the first one that I'm going to introduce to you today is Bruce Ketrick. And Bruce Ketrick has just been an incredible mentor to me, and I accredit a lot of what I am able to do today as a water treatment consultant, as a water treatment business owner, as a podcast host, to the fact that Bruce took the time to work with me and help mold me into the water treater that I am today. So folks, we're going to listen to our next question with Bruce Ketrick, CWT. Well, Scaling Up Nation, you know that Industrial Water Week is just such a big deal to us water treaters, and why should I have all the fun? So our next question, I have one of my mentors on the show, the esteemed Bruce Ketrick, CWT. How you doing, Bruce?
I'm doing fine. I didn't realize I was esteemed. I'm starting to feel older now.
Well, I'm not calling you old, but in my heart, you have a very, very solid place in there.
Thank you.
Well, Bruce, let's take a listen to James McDonald's question, and let's see what you think.
Happy Boiler Tuesday of Industrial Water Week. My question for today is, what are the maximum recommended cycles of concentration for low-pressure boilers using high-purity makeup water, such as reverse osmosis or demineralized water?
Well, this has become something of great interest in the industry because the old standard was 1% minimum blowdown to make sure solids were removed efficiently from the boiler. Unfortunately, that was all designed when we only use soft water. with the introduction of reverse osmosis to a lot of boiler systems, due to the fact that there's tremendous energy savings with reverse osmosis water, as well as the fact that it's now become economically feasible to use in boilers, that has changed the concept entirely, because with RO, your solids level are lower, your treatment level is much lower. Hence, to remove the solids, you can reduce your blowdown. And in many cases, we're finding that 0.2 to 0.5% blowdown is more than adequate. So as far as how many cycles are concerned, there really is no limit per se. Let's take a Midwestern water with 800 to, say, 1,000 micromoles of conductivity. You run that through reverse osmosis, you're going to have somewhere in the neighborhood of 20 micromole water. Well, even if that's 100% makeup, at 20 micromole water, you're going to be 100 cycles at 2,000 micromoles, 150 cycles at 3,500. You bring into the fact that you will have condensate return, obviously. You could be looking at the situation where it would be difficult in one of those boiler systems, especially with high condensate return, to be able to even get to 1,200 micromoles conductivity in the boiler. So the limiting factor becomes the fact that you still have to have some blowdown. You are still feeding some dispersant, but it really is on a case-by-case basis. And you're going to have to make sure you have somewhere in the neighborhood of 0.2 to 0.5% blowdown, just to make sure you've removed some of the solids that accumulate in the system. Other than that, it's balancing the chemistry.
That's some great information. Bruce, let me ask, I know years past, we didn't see a lot of RO on boilers, but that's changing. Does it make sense that eventually we're going to see more and more RO on systems in the near future?
I would say we are. One of the reasons for it is very simple. The cost of reverse osmosis equipment has come down dramatically. So your initial investment isn't that high, along with the fact that energy is an extremely limited quantity and an expensive quantity. So with the tools that we have today to be able to calculate energy use within a facility, you can take a look at a lot of these plants, and the use of RO for boiler application pays for itself in less than a year in many cases. That type of payback is a good investment because they can project it out. We're finding that a lot of facilities are using reverse osmosis for production. Well, if they size them for max production, that means during a lot of times during the operating period, they have excess RO water. Well, why not use that in a boiler, since you have to generate with reverse osmosis at a fixed rate? It's not a variable rate piece of equipment, which is why it requires storage tanks. And that's one of the limiting factors, is the size of the storage tank and the footprint available. But if you have that, large printing facilities, for example, or beverage manufacturers, all have to produce reverse osmosis water for their application in fairly large quantities. The amount required for a boiler, especially if it has over 50% condensate return, is minimal. The energy savings is immediate because they've already made the initial investment. So we're seeing more and more of that. The other part is I do a number of different lectures to design engineers that build boiler rooms. And especially in the Midwest, where we have higher conductivity, higher solids water, and it becomes a very expensive situation because of the high blowdowns required. They're recommending and designing in reverse osmosis more and more because there's an immediate energy payback. So I think we're going to see that gradually spread across the country.
Bruce, I can't help but take from what you just said that, we're water treatment professionals, and there are a lot of people out there that they just spend all of their time in the mechanical room, and then they think, oh, that's the process. I have nothing to do with that. But if you can take a machine like an RO that they already have and make it even more valuable to them, that's thinking outside of the box, and that's being a real water treatment professional.
Well, that's what our job is, actually.
And I agree. And thank you for telling the Scaling Up Nation that. Well, Bruce, since I have you, I'm not going to let you go that quickly because you answered the first question so well. How about we try one more?
That's fine with me.
All right. So next up, we have Mark.
Hey, Trace, it's your buddy Mark Jewell. Hey, I have a two-part question for Steam Boiler Day of Industrial Water Week. What resource do you use to differentiate between high pressure and low pressure And what treatments change as boilers operate in the hundreds of pounds of pressure?
Well, in response to Mark Jewell's request, there's two different ways we look at this as far as treatment in boilers. The difference between low pressure and high pressure boilers in most utility applications is at 650 psi. And the main reason for that is at 650 psi, you're approaching the temperature at which the silica in the water becomes volatile and will carry with the steam. So your chemistry has to dramatically change. The most dramatic change is that the blowdown of the boiler is based on silica levels. At that point in time, you're usually using demineralized water or what they call a desilicizer. And a desilicizer is nothing more than an anti-exchange tank from a demineralizer. And you monitor silica because silica is the first thing to be released from that anion exchange tank. Silica becomes critical because once it volatilizes, it then will condense back out and become silicaceous deposits on turbine blades or in other parts of the application. The other concept is what most of our AWT members look at, and they look at a lower pressure boiler being below 30 psi and a higher pressure being 100 to 250 psi. The chemistry under 300 psi is all pretty much the same. The reactions don't change that much. As you get over 300 psi, you're going to have to look at different oxygen scavengers in particular, because sulfite is not as functionally capable of tying up oxygen in the higher pressures. It breaks that down into elemental sulfur. And the levels you're allowed to use start to diminish to the point where you're below 20 ppm. So some of the reducing agents as DHA or erythrobics or quinones or such are used once you get over 300 psi and definitely have to be used over 600 psi. As a matter of fact, the more popular ones at that point are the carbohydrozides and DHA in particular. In the below 30 psi boilers, what you're looking at is usually heating boilers, high condensate return, things along those lines. In those applications, that's where our one drum treatments come into play, where we're actually looking at more oxygen scavenging, running a sulfite at a level anywhere from 30 to 60 parts per million, as high as 80 parts per million, and then a good dispersant because you've got a very high condensate return. One of the problems is taking a boiler that's operating at 100 to 150 psi, deregulating it down to 15 psi without changing the actual steam release section. Because when they're designed, the lower pressure boilers are designed with a steam plate that actually allows the steam rising from the boiler to impinge on the plate, knocking the water back down before it goes to the actual dry box. Your 100 to 150 psi boilers, 200 psi boilers, let's say, don't have that because they actually have back pressure from the pressure of the header to help with that, and a distance from the steam release port up to the main header itself. So when you deregulate a system like that, if you don't put additional steam baffles in to knock the water back in, you'll end up with some carryover situations. The basic chemistry is based on the pressure or volatilization of the impurities. So the normal cut rate, as I said, is right around 600 psi and above become a very separate chemistry. No precipitating chemistry above that, no phosphonates, very limited dispersants. Only a few of the dispersants like PCA or some of the amps actually will tolerate those temperatures without breaking down. And in most cases, it's high purity water, very little, if any, alkalinity, usually like a positive 10 OH, but can be as little as 1. The chemistry is almost purely coordinated phosphate situations where you measure the phosphate versus the molar sodium in the boiler. Below the 300 psi is the standard. We have dispersant, we have an oxygen scavenger, we maintain an alkalinity of a minimum 200 to 250 OH and a condensate return based on the type of system.
Bruce, what are some of your favorite boiler resources?
My favorite boiler resources?
Yeah, so what books do you go to because you know everything, so you don't have to go to books, but somebody like me, and I have to go reference something, what do you recommend?
I would say the GRTM. How's that one?
All right, well, that's definitely a good one. Anything else you can think of?
Yeah, I'm a book collector. I've got Nalco's book. I've got 3 different versions of the Betts book. I've got the Drew book from 30 years ago. There's a Bermuda book that went out of publication 50 years ago, which probably has more information on actual corrosion cycles and reactions than anything else that's out there. They handed out a little pocket book that has every type of reaction and detail you can think of, which doesn't exist in publication anywhere else. And unfortunately, some of the things I look at are held together with spit glue and Scotch tape.
I remember my dad's library, and that was very similar. Well, Bruce, thank you so much for coming on Scaling Up and participating and answering some questions in Industrial Water Week.
It is my pleasure.
Scaling Up Nation, I tell you, I would be lucky if I knew 10% of what that man has forgotten. I just think he is incredible. And when I have a question that I cannot find the answer to, he is one of the guys that I go to. Bruce, thank you so much for all the support that you've given me. And because of that, that allows me to do what I do in this podcast. Well, folks, another message I hope that you get from Industrial Water Week is that nobody is an island. If we were just out there by ourselves, we would not need a holiday for all of us. But Industrial Water Week, if it doesn't do anything else, it needs to remind us that we are there to help each other grow more than we are now. I hope this show inspires you to do that, but more so, I hope you're inspired to not only grow yourself, but reach out and grow somebody else in the water treatment community. I know at first you're thinking, well, wait a second, they're my competition, and if I do that, I'm going to lose an advantage. Folks, there is no advantage in this business. There is no secret sauce that any of us do not have the ability to go out there and produce. The only thing that we can do is help each other make this industry better. And I promise you, whatever you give will come back to you tenfold. And that is how you're going to get an advantage over everybody else. So don't believe me? Well, try it. And if it doesn't work, I'll give you a money back guarantee. How about that? Folks, can't wait to talk to you tomorrow. Wednesday, we're going to be talking about cooling. I have another mentor of mine on the show. I know you're on suspense. You can't wait to hear who that is. So join us tomorrow as we dive into Industrial Water Week, Wednesday, cooling. Have a great rest of the day, folks.